Hey guys, last time we talked about 7.4. In there we learned about the two big concepts, which were the coterminal angles and also the reference angle, right? For coterminal angles, all six trigonometric functions have the same value, but then for reference angle, we have two requirements. The values would be the same, but then the size, they can be the same and they can be opposite to each other, okay? So watch out for the side of reference angle also, okay? And then we also learn about the four quadrantal angles, which are the 0 degrees or the 360 degrees, and then the 90 degrees, and then 180 degrees, and lastly, we have 270 degrees, right? And then if your angle is not one of the four quadrantal angles, then it must lie on one of the four quadrant, right? And then, for example, let me draw the four quadrant like this. Let have like the x and y axis like this first, and then we're gonna have question 1, question 2, question 3, and question 4, right? And I told you guys there are rules to remember, like the positive signs of all the six strict functions is that we have all student tech calculus. It means that on the first question everything, like all six of them, are positive. On the second question, only sine and its reciprocal, which is cosecant, are positive. The rest of them will be negative, right? On question 3, we have tension and cotension being positive, and in question 4, we have cosine and secant being positive, right? And then that's it about like 7.4, and I know 7.4 is like a big one. So then if you have any questions on that, please make sure you ask me, like just to make sure you understand all the concepts of 7.4 before you watch this video about 7.5, okay? So now let's talk about 7.5. So today is going to be like a short one, and the first slide again is like a quick review of what we have learned before. So this table, the definition of the six trig function, goes by Sokotoa. I'm not going to fill it in for you guys, but then please fill it in. Please try to challenge yourself to fill them in without looking back at the old worksheets, okay? And then this is the picture, the image that I asked you guys to remember from the last worksheet. Again, we're gonna have like the four quadrantal angles in here, and for each of them we're gonna have like a point like corresponding to them. So in here we have like 1 0, and then 0 1, and then negative 1 0, and then 0 and negative 1, right? Because we're in a unit circle, so all the edges of all the points in the circle in here, they all must be 1, okay? And then the big thing I told you guys to remember from this picture is that make sure you guys remember that the x part is a cosine and the y part is sine, right? So for example, let's say if we had something like, if I'm asking you guys to give me like the cosine value of say 270 degrees, then you guys gonna tell me that's the x part, which is 0, right? And if I ask you to find like the sine value of say 90 degrees, you guys gonna tell me that's the y part, and it is 1, okay? So make sure you guys can tell the difference between like all the points in there, and then between the x and y in here, okay? And then a quick notice is that we're gonna have like zeros sometimes. So then say if I'm asking you guys to find like cotangent value of, I don't know, like 270 degrees, or I can ask you guys to find cotangent of 3 pi divided by 2, right? It's like the same angle, it's just different names for them, okay? And then for this case, because cosine of 270 is already 0, so cotangent of it is going to be like cosine divided by sine, which is like 0 divided by negative 1, so the answer would be 0. But say, if I'm asking you guys if I like tangent of 270 in here, it's going to be sine divided by cosine. So then cosine here being 0 and it's on the bottom, so then tangent value of it will be not defined, or you can write d and e, which is like doesn't exist, okay? So now let's talk about like the first objective of today. Oh, not even the first objective of today. Okay, so this page I put it in there. It's not going to be on the test, and I'm not going to test you on this. It's just like interesting facts that I found, okay? Like it's really cool. If you want to know like the meaning of every like of each of the 6 trigonometric functions in the unit circle, they all have like the meaning, right? Like each of them measure a distance that is relative to the point, to the angle that we pick in there. So everything on the unit circle is about a point, and it's also about the angle, like the original angle. When I say original, it's like the adjective of like the origin. So original angle is like, you know, like the angle that stay around the origin, okay? So each of them will have like a value, right? Like the sine here would represent the y part of the point, which is b in here, and cosine it would represent the x part, which is a, and then tangent it is like this distance of like like the hypotenuse inside this specific right triangle, and then you can interpret like the rest of them by looking at the color and then the distance of them in here, okay? And then again, I'm not going to test you on this one, and you're not going to see them on the homework, but again, just read them because I feel they are really interesting. So if you want, just read them, okay? And now let's move on to the very first objective of today. Find exact values of the trigonometric functions using the unit circle. Okay, so we have the unit circle, but I'm not going to go too deeply into the unit circle because, like I said from the last worksheet, I personally didn't learn a lot about a unit circle. I passed trig without a unit circle, right? And I don't recommend using the unit circle because I don't want you guys to just remember like everything instead of unit circle without meaning, okay? Like we learn math for a reason, right? Like we better know what we're doing for math, right? Not just like memorization straight, okay? So just like the textbook in here, we're gonna have like some definition by using the unit circle, but again, like everything is based off of the right triangle, right? And I believe just by using the definition of SOHCAHTOA you can get it down to everything, okay? So let me talk through this table of definition right here. So for example, let's just have like the x and y coordinate like this, x, y, and for example, let's say we have like like a point here, a comma b. Okay, my a looks weird, so let me fix that. A comma b. Okay, and then we're gonna connect it toward the origin and also project it down toward the x-axis to create like a right triangle, right? Just like the last worksheet, right? And okay, just because we're talking about like a unit circle, right? So then the radius of a unit circle would be 1. And if you ask me where is the circle, if we were going to talk about a unit circle, I'm going to tell you the unit circle is actually right here, okay? So AB is a point on the unit circle, okay? That's why the radius in here, it will be 1. And this radius in here is also the hypotenuse of the right triangle that we're having, right? And let me put it back in red. The x part in here is the x part in here is A. So this is A, and then the y part is B. And again, our angle is like toward the origin. So let me just like color it right there. Okay, so that is our theta, right? So B in here is our opposite. A in here is our adjacent. And the 1 in here, the radius, it will be our hypotenuse, right? So by that, we can write like all 6 of them based on A, B, and 1, right? So sine here is SOHCAHTOA, so psi is opposite divided by hypotenuse, which is which is B divided by 1, and then B divided by 1 is B, right? So that's why we only have like psi of theta equals to B, right? And then we can do the same thing for the 6 of them. I'm having the answers in here, so I'm not going to waste your time like explain all 6 of them because everyone seems to get this one really well on the first quiz. Okay, but again, if you do have questions on any of these, please let me know, okay? And then for my personal tips, I have know that a equal to 0, that is, if the point P is on the y-axis, the tangent and the secant function are undefined, okay? So what does it mean? Well, as we can see in here, like if a equal to 0, let's look at the tangent and let's look at the secant in here. Well, for these two functions, since a is on the bottom, right, and then we know for the fact that we cannot divide anything by 0 because that would be like the case of undefined. That's why I'm having like this tip in here, right? And with the same logic, let me put it in like, I don't know, pink. If b equals to 0, let's look at cosecant and cotangent. Wait, mark the wrong one. Okay, so for cosecant and cotangent with a similar logic, again, b's are on the bottom in here, and if, say, b equal to 0 in here, your denominator will be 0, and that would be the undefined case. Okay, so that's my tip, okay? That's like my personal tips to you guys. And because we use a unit circle in these definitions of trigonometric functions, they are also sometimes referred to the circular, okay, accent, but yeah, circular functions. Okay, so this is like another name for the unit circle, or like the trig functions. Okay, and again, this is just like extra information, so I'm not gonna test you on the name of it. Okay, but it's just like, interesting facts to know. Okay, so let's talk about the very first example for the values of trigonometric functions using point P, which is on the unit circle. Okay, so let me put it in red, and let me just like draw the coordinate again. So we have like x in here and y in here, and then this is negative and this is also negative, right? In which quadrant both of your like coordinate are negative? We're talking about quadrant 3, right? So let me just make a point here, and then connect it toward the origin, also to the x-axis, to make a right triangle. Okay, and this is the x part, and then this is the y part, right? So for x, I'm gonna get negative 4 over 5, and then for the y part, I'm gonna get negative 3 over 5. Okay, and then because we talking about on the unit circle, right? So then the hypotenuse in here will be automatically 1 because of the word unit. If you don't trust me, again, we have the tool of Pythagorean theorem, right? So you can plug into the formula of a squared plus b squared equal to c squared, and the result, of course, if you do the right procedure, if you do the right algebra for it, the hypotenuse in here, the radius in here should be 1, okay? So now let's talk about the angle. I told you guys the angle is always around the origin, so this is our angle. So then that turned negative 4 over 5 to be adjacent, and then this is the opposite, and then the 1 in here is the hypotenuse, right? Again, I'm just gonna go through the answers like really quick, because they are just, like what we already have learned, right? And then if you see the symbol T in here and it trips you, okay, T is just like another kind of like symbol for like angle in here, okay? In real life application, T can be represented like for the time, if you want to like look it up on the textbook and to like the slide in here. So say at the first moment when you at like time 0, you at here, right? You're gonna have like different values of all 6 of them, and then at this moment, say at the time being, I don't know, like 10 seconds after that, you're gonna have like different 6 trig functions or like values for them, right? And I'm not gonna, I told you guys, I'm not like into the unit circle, so I'm not gonna like talk deeply into the unit circle, but just in case you guys have like math major and you guys want to know like the derivation of the unit circle, there we go, just ask me, okay? I can talk more about that, of course. Okay, so that's like the explanation on why you're having T instead of like theta, like usually. But again, don't worry, T or theta, it just means like the angle that we having in here, okay? So as long as you get the answers right, that's like there, okay? So psi, SOHCAHTOA, we have opposite divided by hypotenuse, which is negative 3 over 5 divided by 1. So the answer in here will be negative 3 over 5, okay? Cosine, it is so adjacent divided by hypotenuse, which is negative 4 over 5 divided by 1, which is also negative 4 over 5, okay? The big one, tangent, it is opposite divided by adjacent. So if we have to divide 2 fractions, I'm going to give you guys like a kind of like a method. I call it keep, flip, multiply. So I keep the first fraction as negative 3 over 5. I flip the second fractions, and then I already kind of like explain what a negative should stay on the top or in the middle. I don't personally like to see the negative on the bottom, okay, because it just looks like weird and ugly, okay? And then lastly, I have like multiply in here, so instead of doing division, I'm gonna have like multiplication in here. So this is K of M, okay? Like, don't think about it as K of C, okay? Because C, it doesn't mean like multiplication or anything, okay? So just remember it as keep, flip, multiply, okay? Keep the first fraction, flip the second fraction, and multiply the 2 fractions together, okay? And before we multiply the top with the top and the bottom with the bottom to get a new fraction in here, I will highly recommend to cancel as much as we can, right? So the 5s will go away, and also the negative times the negative, we're going to have a positive number, right? So at the end, we're just going to have like the 3 on top and then the 4 on the bottom, okay? And for some of you guys who might ask like, well, if the 5s are canceled, then where did it go, right? Well, each of them will be replaced by a 1, okay? Because 5 goes into 5 one time, and then the other one, same thing, right? Like 5 goes into 5 one time, okay? So on the top part, we're going to have like 3 times 1. That's why we have like 3. On the bottom, we're going to have like a 1 times 4. That's why we have 3 over 4, okay? So then tangent, the answer of it will be 3 over 4. Okay, for the other side, we're just gonna flip them. So I'm just gonna write them down really quick in here without like explaining them. But then again, if you have any questions on this one, please let me know. Okay. And for your part, let me just put a green star on this one. Okay. And then next objective, use the periodic properties to find the exact values of the trigonometric functions. Okay, so let's talk about period. Okay, so a function f is called periodic if there is a positive number p, such that whenever the angle theta and another angle theta plus p are in the domain of f, then f of theta plus p equals to f of theta. Okay, so this is a lot about like math concept. I'm gonna okay, if you don't remember this formula right here, that's okay, because I personally don't remember it, but I have like a better way to show you what it means when we learn about the graph of each of the 6 trigonometric function, which is like 7.6 and 7.7. okay, so don't worry too much about this concept in here. I'm gonna explain it about the meaning of periodic functions later on when we talk about the graphs. Right, for now I'm gonna show you guys that like the period of like the 4 functions, sine, cosine, and their flips, secant and cosecant, the period of all 4 of them is 2 pi. Okay, and for the other like 2 functions, tangent and cotangent, the period of them is pi. Okay, right now just like remember that the period of like all 6 functions are different from each other. The first 4 is 2 pi, and then the other 2 is pi. Okay, don't mix them up. Okay, don't think of them as like all 6 of them have the same period as 2 pi or as pi. Okay, you have like different periods, and make sure you can tell which one has the period of 2 pi and which one has the period of pi. Okay, for the meaning of them, I promise you guys I'm gonna explain about them in the next lecture. Okay, in the next sections. Okay, let's talk about the periodic properties. So like I said before, technically the sine, cosecant, cosine, and secant, as you can see, they all have like the 2 pi, right? So then if you add like a 2 pi to an angle, meaning like if you go like a circle to get back to yourself, then the value of like the trig function will stay the same. For example, let's say if I have like 30 degrees, and if I go back to itself by adding like 360 and another circle onto it, then I'm gonna get like 390, right? Then the sine values of these 2 angles are the same. The cosine values of these 2 angles are also the same. And okay, this one, it has like a bad mark, so let me mark it again. And then the cosecant value or like the secant values or these 2 functions are the same. Okay, but then it doesn't take that long for tangent and cotangent to reach to the same angle, value. For example, for 30 degrees, you only have to add up like 180 to it, okay, so that you have the same tangent and cotangent value. So for 30 plus 180, we're gonna get like 210 degrees, right? So then these 2 angles will have the same tangent and cotangent values. But for these 2 degrees, for these 2 angles, if you want to check it in the calculator, their sine will be different, their cosine will be different, their cosecant will be different, and also their cosecant will be different. Okay, so let me just put like the number in here so that you know that the second pair, it only works for tangent and cotangent, while the first pair, it works for all 6 of them. Okay, if you want to test it out, go ahead. Okay, so then now for my tips, I have tips to use periodic properties. We keep subtracting or adding 2 pi or like 360 degrees from the given angle measurement until we get a positive value within 2 pi. Okay, so let me highlight the word positive in here. So we need to do it like we keep adding or like keep subtracting 360 to the original value until we have a positive number. Okay, if you still have a negative number, that means you still have to add up like 360 to it. Okay, and then make sure your value, make sure whatever you're adding in here, it must be within 2 pi. Okay, so let me put it back to red. What do I mean within 2 pi in here? It means that it must be lower than 360. If you have something like, I don't know, like 361, then that means that it can still be like subtractable by like 360, right? So you have to take like 361 minus 360 to get one degree, right? And then that 1 degree is the angle that we want to find. Okay. So let's talk about the example on my part in here. So I have like two angles in here, and I promise you guys, this one will be on the test and also on the quiz. So make sure you keep you stay tuned for this one. Make sure you pay attention to this problem in here, okay? Because I know it's hard, and I also know that like it's complicated. Okay, so if anything, just ask me. Okay, so first of all, we have like 600. Okay, so like I said, this one is a big number, and I don't want to keep like drawing it around. So then let me just subtracting it with 360. And then let's see what I have in here. I'm gonna get like a 240, right? And this number in here, 240, it is less than 360, right? And it is also positive, right? So that's a good angle to me. So let me draw the angle of 240. It should be on the third quadrant, right? So I'm just gonna draw it random at there. Okay, this is my angle of 240. And in the test, you have two options. You can either draw the angle of like 600, or you can draw the angle of 240. I'm not going to judge you on this one, okay? Because honestly, I don't even want to draw the angle of 600. It looks a little bit, like complicated, and it takes it rows and rows, right? So I don't want to do it as well. Okay, so that's about the first one. And then how can we figure out the cosine value of 600, right? So we know that 600 is the coterminal angle of 240. So then cosine of 600. Okay, let me move this one a little bit further so that I have space in here. So cosine of 600, it equals to cosine of 240. Okay, just because they are coterminal angles of each other. Okay, and we also learned about the reference angle, right? So here's the terminal side, and here's the piece of x-axis that is closer to the terminal side. So again, I'm gonna do the pink double arc to represent the reference angle in here. And because this one is like 240, right? So to find the reference angle in here, the best way that we can do is that we take 240 minus 180, okay? Because of the position right there, okay? So I'm gonna have like, what is it, 6 in here? So 60, right? So the reference angle in here is 60. So then we're gonna get cosine of 240 degrees equals to either plus or minus cosine of 60, right? The plus and minus because like 240 and 60, they are reference angles of each other, right? So the plus and minus, they have to stay there. You cannot set them to have like the same value without like checking the quadrant. Okay, so let's look at the quadrant where the 240 lies in, right? So 240 as the terminal side points at, we lie in quadrant 3, right? So we're gonna do all student take calculus. Let me put it in orange. All student take calculus. So in quadrant 3, tangent is the only thing with positive value, right? And as well as like cotangent. But we're talking about cosine here, right? So that's why cosine here, it has to be in negative. Just because of the quadrant that 240 lies in. Okay? So then let me take out the two sets in here and just put a negative because of the position of the angle of the terminal side. Okay? So now, we know that by the chart that I kept like usually mention to you guys, or if you want to, you can even plug into your calculator. Cosine of 60, it equals to 1/2, right? And because we have a negative in front, so it's gonna be negative 1/2. Okay. So then for the first part, let me take out a circle. For the first part right here, we have cosine of 600. It equals to negative 1/2. Okay, that's one of them, right? We still have like tangent of 495, right? With the same logic, first of all, let's subtract it with 360. So let me cut out some parts in here first. Delete. Okay, this is like really cool and fast. All right, so for 495, minus 360. We're gonna have 5 in here, 3 in here, and 1. We have like 135, right? And this is like less than 180. So that's the side that is gonna lie on the second quadrant right here. Okay, and then after that we're gonna find a reference angle. So reference angle, it should be this one. And again, if you don't know how to find a reference angle, please let me know, okay? Because it's really important. It's gonna be on the test, it's gonna be on the final, and most recent to you guys is gonna be on quiz 2, okay? So the reference angle in here, it is 180 minus 135. So then it is a minus 4. This is 45, right? So we have 45 degrees right here as a reference angle. All right, so that's the easy part, right? Like defining like all the reference angle, and then just do with like addition and subtraction algebra part. Now let's talk about the value, including the trig functions, right? So we have tangent of 495 equals to tangent of 135. Okay, let me see if I can squeeze this in. Yes, I can. Okay, because these two are coterminal angles of each other, right? But then the next reasoning, we have tangent of 135 equals to plus and minus, or minus tangent of 45, because the 45 angle degrees is the reference angle of 135. So now we have to determine whether it's a plus or a minus, right? And then as we can see, the terminal sign here is pointing toward the second quadrant, right? So then let me just put like second in here. And we have all student tech calculus. In quadrant 2, only sine and cosecant are positive, but we having tangent in here, right? So that means that tangent in here is also negative, right? And again, like in the examples that I show you guys in here, I purposely make it negative so that it looks hard, but it could be positive also, right? Like depends on the quadrant where your angle or where your terminal side points to. Okay, so just be aware of that. So then tangent here in quadrant 2 is negative, right? And then as for like the number in here in the chart, or if you want to put into the calculator, tangent of 45 is 1. And because we already have the negative in front, so that's negative 1. Okay? So now let's put everything together. So we're going to have negative 1 for the second part of tangent of 495, right? And we have division between them. And everything, okay, first of all, let's cancel out the negatives. And then everything divided by 1 is itself. So then the answer for this part is 1/2. Okay? So I know it's hard. It takes a lot of work. It has like the concept of coterminal angles, and it also has the concept of reference angle. Okay, and it also like involves a lot of pictures in here, and then values. So you guys have to kind of like know and memorize. But again, like yeah, these are like the most important things on trig. Okay, so make sure you guys like understand it, and then just let me know if you guys have any questions. Okay, and as for your part, this is like your problem. Okay, and then let's talk about this, the very last objective of today. Use even odd properties to find exact values of the trigonometric functions. Alright, so if you recall from algebra, we have two types of equations, even and odd, right? So even functions are defined by the one that has the property of like f of negative theta equals to f of theta. Okay, and then for odd functions, it has the property that the negative will be like pulled out to the front. Okay, so again, for even functions, the negative is canceled, okay? And then for odd functions, the negative will be pulled out to the front, okay? It's about the algebra, so I'm not going to test you on this one. So don't worry too much if you like don't get this part. I'm going to explain it later anyways, okay? And then let's talk about like the point that we had earlier. Like let's talk about like a point AB on a unit circle, okay? And then again, the letter A in here is stand for like the X part. B in here is for the Y part. And then if you guys remember, X is for cosine and then Y is for sine, okay? Make sure you don't mix it up, okay? And that's like one point, we call it P, right? And then let's say we have like another point Q. And also on the unit circle with the angle negative theta. Okay, so P, it relates to the angle of theta, and Q, it relates to the angle of negative theta. Okay, and by the position of them, automatically Q has the coordinate of A and negative B. Okay, so as you can see, A stay the same because they like have the same X part, but B, they are in different size. Okay, because they have like opposite Y direction, opposite Y values. Okay, so just by looking at the graphs in here, okay, I'm not gonna, okay, if you don't want to go into like why or like how which one is negative or positive, that's cool too, but at least just remember one thing. Okay, the only two even functions that we have in here are cosine and secant, and a trick to remember this one is that notice that the A part in here stay the same, right? Like the A part they the same, right? And the A part is actually cosine, right? And the flip of cosine here is secant. That's why for A parts they stay the same, and hence the cosine and secant are even functions. Okay, for the B part, because they're changing the side, right? Because they look across each other, because of like, you know, the position of the angle theta and negative theta. So then sine would be negative, I mean psi would be odd, right, function. And then the flip of psi, which is cosecant, would also be odd function. And tangent and cotangent, I have no good way to remember them, but technically they following the sine values. Okay, so then just remember one thing: the only two functions that are even in here are cosine and secant. The rest of them, the other four, are all odd functions. Okay, so in here for 6 trigonometric functions, your function can either be odd or even. Okay, they cannot be both, they cannot be either. Okay, please remember that because it's going to be on a test. Okay, and then let's talk about like the even odd properties. I told you guys from earlier, the even functions, the negative will be canceled. Like, what do I mean by the negative in here? The negative angle will turn out to be a positive angle for even functions. Okay, and then for odd functions, the negative will be pulled out to the front. Okay, so if anything, just remember that. Okay, like for example in here, tangent of negative 135, because tangent in here is odd, so I'm gonna pull out a negative to the front, and once I pull out a negative on the inside, my angle will be positive. Okay, so just keep that in mind. Okay, and for the second part, for the secant, it's also, no, secant in here is actually an even function, right? So the negative, it will be canceled by itself. So from a negative angle, it's just gonna turn to a positive angle with no compromise. Okay, and now what's next? Well, we having the same situation as the last time. So first of all, let's draw them out. Let's find the reference angle of it, and then let's decide like the psi of the function and also the value of the function. Okay, so the first picture is for the 135 degrees, so it should be on the second quadrant. So let me try it right here. Okay, and then let me just put like second in here. Okay, so for 135 degrees, the reference angle of it, we're gonna take 180 minus 135 degrees, right? And then that is 45 degrees. So the reference angle of it is 45. So then this equals to negative tangent of 45. The negative is just like a carryover, okay? Like it doesn't mean much, but it's just a carryover. Like originally, if you have a negative, make sure you carry it over. Okay, originally, if you don't have a negative, please don't make up a negative and put it there to make it look negative. Okay, it's not gonna work. Okay, and as like lastly in here, if you have like the calculator, make sure you input the tangent of 45, or if you want to remember it like me by the chart that I told you guys earlier from the last worksheet, this value is 1, and because we have a negative in front, it's gonna be negative 1. Okay. And let's do the same thing, but for secant of 120. Okay, so let me take this one out first. Alright, so let's draw out the angle of 120. Where's 120? It's bigger, well, it's in between 90 and 180, right? So it should be on the second quadrant. Okay, so it's there. also on the second quadrant. All right, so now what do we do? Okay, that reminds me of one thing. We didn't even check anything on the second quadrant on the last problem, so this might be wrong and I have to explain it later. But well, let's just talk about the secant first. Okay, let me put like somewhere the second two so that later on I have like space to explain this. Alright, so let's talk about the reference angle of this. The reference angle of 120, we're gonna do 180 minus 120, and that is 60, okay? So the reference angle in here, we have 60. So that means that secant in here equals to secant of 60, okay? Okay, so earlier we don't have any negative, right? So when it's like brought down over, it's not going to be negative. But here's the thing, right? We talk about the second quadrant, right? So then in second quadrant, we have all student take calculus. So student in here, it means that we're going to have sine and cosecant being positive. But it doesn't say anything about secant, right? So that means that your secant is still negative, right? So let me just input like the negative in here. This negative is not a carryover. It's for the quadrant negative, okay? So then the final answer in here is going to be negative answer first. And then I don't know the value of secant of 60 right like on top of my head. But I know for the fact that secant is the flip of cosine, right? So instead of finding like secant of 60, I'm going to find 1 over cosine of 60. And cosine of 60, it is 1/2. So I flip it and I got 2, okay? So then for the secant of 120, we have a 2. And like I promised before, let me erase this one a little bit in here. Let me go over this one real quick. Okay, so same logic. First of all, the negative is a carryover, right? And then tangent 45 because it's a reference angle. But before we move on, right, because the 135 is also on the second quadrant. And on the second quadrant, again, all students take calculus. It tells you nothing about tangent. That means that tangent in the second quadrant should have a negative value, right? But on top of that, we already had a negative, right? So then 2 negatives to come in, we're going to have a positive value, okay? And again, I know this is confusing, so if you have like any questions on this one, please let me know, okay? And then, let's see, what do we have in here? So we have it equals to a positive 1, okay? So then what do we do is that we're going to add up these two numbers. Why do we have to add up these two numbers? Because we have addition. So then the final answer in here would be 1 minus 2, which is negative 1. Okay? And then as for your part, let me put a green star in here. And last page, I give you the unit circle. Just comes in handy just in case like you need to use it. But again, I'm not going to like go in depth with the unit circle because I personally don't like the unit circle. But if you find it helpful, please make sure to print it out to get ready for the tests and quizzes, okay? And I know like a quick way to remember everything inside the unit circle, okay? So if you want, I'm not gonna waste your time like explain it in this lecture video, but if you want, you can schedule a Zoom meeting with me and I'm gonna show you the secret to remember everything inside a unit circle, okay? So that's about it for this today, for this lecture today, okay? So thank you for your listening and take care. Bye-bye.